Yeah, so good evening, students. Oh, Maya is out of network. Good evening, students. So please switch on your cameras. First of all, Narendran, Rujuta, Shayan. Please switch on your camera, Shayan. Okay, so now we are moving to the chapter number one of this particular physics. Okay, which is the highest weighted chapter of physics. Okay, this marks from this chapter is from 10 to 11 marks. So the highest weightage is light chapter, followed by electricity, followed by human eye, and followed by this particular electromagnetism. Okay, okay, students. So that is what this chapter is of. Okay, so definitely, when I start sample paper, I'll discuss which question, which subtopic will give how much questions. Okay, I'm just going through actually this particular previous questions format. Okay, definitely, even though this time format has been changed, but the weightage will be almost same, student. It can't happen that from human eye he is giving 15 marks, and from the first chapter he will giving it 3 marks or 4 marks. It can't happen because we don't have so much content in human eye. Okay, even though I took it for 7 sessions. Okay, human eye, believe me, I can close it in 2 or 3 sessions, but I took 7 sessions because that's a strong foundation for your class 11 actually. Okay, okay, no problem. So today we are starting the chapter number one, light chapter, student. So this chapter I have taken for 11 sessions in my general session. Okay, so student, I'll try to close it in 2.5 sessions. Okay, revision. I can't close it in 2 sessions because it's a very big syllabus. And some of the students who have joined later, they are also in my batch. So I'm going some little bit slow for this particular chapter. So I don't know. I may plan one more extra session like Sunday. I think this Sunday it worked out well. So if you all are interested, I may take next Sunday also. At least this I'll complete this particular first chapter. Let us see. Let us plan it on Saturday about the next Sunday session. Okay. So right now I am planning to close this session 2.5 to 3 sessions. I'll revise it. 2 sessions I'll go for sample paper. Total 5 sessions I am planning, student. Okay. Okay, student. With that, let us start today's session. Okay. Okay. So yes, Maya. Okay. Shayan. Okay. That's all. Where are others? Megha, Avdan. Okay. So student, how did I start this chapter? Do you all remember? This is the first chapter. I think first class we have started the physics only. Light chapter only we have started. The students who are with me from the very first session. Okay. So light is a form of energy that allows you to see things around you, which is basic. Whenever you, why do you switch on light? To see the thing. Okay. What information did you get from this point is, this is what the information you got from this point. Okay. To for your brain to feel anything, you need three things. First, light should be there. Second, object should be there. Third, eye should be there. If at all anything from these three is missing, your brain can't feel anything. Okay. Suppose the blind girl, obviously, even though these two are there, eyes are not there, everything is black to her. Her brain can't sense any object. Second, if you feel sunlight is not there, light is not there. Suppose right now I'm in a room full of light. If there is a power cut, even though my eyes are there, even though my objects like tables, chairs, sofas, everything is there, but light was not there, so I can't feel the object. Okay? These two things you know it. What is the third thing you should know is object is also mandatory. Object is also mandatory. What example did we go for? We went for this example. What is this example, student? You see, in the space, obviously sunlight is there. Sunlight is in the space, student, already. And you went into the space, your physical eyes are there. So sunlight is there and your eyes are there. What is missing in space? You feel always dark. The missing thing is object. There is no object. That's the reason. Even though you have these two, you will feel dark in the space. Okay. Okay, student, that means all these three things is important for our brain to feel the thing. Okay. Now, how this light is reaching to your eye, what all pattern or what all phenomenon this light is following. See, student, light will follow many phenomena. What are the phenomenon? Reflection, refraction, diffraction, scattering, dispersion, absorption, interference, polarization. These many things light will adopt the phenomenon. But you know, class 10 syllabus, CBSE 10 syllabus is limited. So we will not read all of them. What all we will read? We will read reflection very deeply. We will read refraction very deeply. We will read diffraction in a lighter sense in the second chapter, scattering in a lighter sense in the second chapter, dispersion in a lighter sense in the second chapter, human eye and colorful world. Yes, absorption, interference, polarization is your class 11th and 12th topic. Okay, so in this way we are starting with reflection. Okay, we are starting with reflection. Okay, Cheyenne, switch on your video. Okay, okay, sure. Let us start with the reflection and refraction of light. Okay, okay. Okay, so how to start with reflection of light? So this is what you need to cover the topic. First of all, you should know laws of reflection. Questions based on geometry also you need to know. After that, we'll go for the refraction of light, rarer to denser medium, denser to rarer medium. Okay, this is so I'll try to complete these parts, but still there will be much more part left over here. Total internal reflection, critical angle, many things are there which I'll continue in tomorrow's session. Okay, students, let us start with the laws of reflection. Okay, before that, I need to understand what is reflection. Okay, which way did I say the thing, student? What is reflection? So I have shown you the reflection video like this. Okay, so whenever there is a light ray falling on an object which is reflecting, this is what is happening. Complete light is reflecting, complete light is reflecting, complete light reflecting back. Okay, then what is reflection of light? I am using the same reflection word, but what is reflection of light? Okay, so let us see, student. You see, there is a sun. If you want to know what is this object, the light ray should fall on this object and should reflect back. So reflection plays a major role in sensing the object by our brain. Okay, reflection of light plays a major role. That's the reason we need to understand reflection deeply. Okay, yeah. So what is reflection, student? You see, there is an incident ray from the sun. Thousands of rays, millions of rays come. I'm analyzing only one ray. Ray is nothing but direction of light. There is a layer, one ray. After hitting this mirror, it is reflecting back. Okay, reflecting back. So now what is this? So bouncing back in the same medium. Okay, you see, from the air light is coming, to the air light is going back. So that is what thing but reflection of light. Okay, reflection of light, student. Okay, now the question comes, sir, the light is coming like this. There is a mirror. On the mirror, other side is silver painted or some other color piece painted, which will not let this green color ray to go here. No, not at all possible. The green color ray is reflecting back. But now the question comes, what is angle of reflection? I am able to see physically there is a surface, there is an angle. Here should be angle of reflection. You see, practically an angle is forming here. Again, the reflected ray is here, surface is here. Here should be some angle of reflection. But student, they both are not considered the angles here. Okay? Why, sir? Why they are not considered? Yes, Rujuta. Why are we not considering the physical angle which are able to see here, but we are considering this fellow?
So because the angle between the normal and the uh, point of incidence, like
Incident ray,
it's
incident.
considered, yeah, it's considered as the angle of
Why?
incidence.
Why like that? I am able to see physically surface here, light ray here. I am able to see some angle is forming. But you are saying no, sir. Take some virtual line which is not existing physically. Then you consider this fellow as angle of incidence. Why?
So because the normal is usually perpendicular to the mirror,
Okay.
and so when the ray is incident on the surface, it formed like the 90-degree line, the imaginary line forms as an
So
interface.
what? Yes, yes. Good evening.
So that is why it is considered, sir.
No, no. You are giving the merit of normal line, fine. But what is the demerit of the horizontal line? That is what I'm asking. What is the demerit of the horizontal line? Okay, let me express it. Okay, so student, I am practically if at all I am considering this. Okay, I am doing this activity at my home. So I asked one of the students. So I am getting 30 degrees with this line. So now say me what is happening at your home. Are you also getting 30 degrees? Why? Because suppose Rujuta is also in Bangalore in India at the same time. Sun ray will reach at the same time. So she should also be 30 degrees. But what Rujuta is feeling there, you see, no sir, I'm getting 35 degrees. Why? Because her her home is at such a surface which is inclined, not horizontal, not planar like my home. Okay. Now Cheyenne will say, sir, I am getting only 25 degrees. Why? Because Cheyenne home is situated at something inverted inside, curved, inverted, invert, curved, invert. That's the reason, student. We can't decide the surfaces. We can't guide how the Earth's surface is. But that's the reason to reduce this effect. So, to you see 25, 35, and the 30 degrees, these all are creating an issue. To reduce this effect, what did we draw? We have said that okay, so these all are creating issue. Here is my house. I'll draw a normal. Now I'll measure angle of incidence and normal. How much? 30 degrees. I'll ask Rujuta. What will Rujuta do? Okay, sir. Here is my home. Let me draw the 90 degrees. Now let me check incident ray and normal 30 degrees. Yes. Now she also ready. Now what will Cheyenne do? From this point, she will also draw normal and she will measure and say 30 degrees. So in this way, we are reducing the demerits of the surfaces like this. That's the reason we are considering this as a normal. Understood, beta Rujita?
Yes, sir, got it.
Got it, okay? So that is nothing but the, so now I have informed three things: incident ray, reflected ray, and the normal line. Okay. Now what does loss of reflection saying it? So there are two important laws. First law, angle of incidence equal to angle of reflection. You would have seen in this particular video also. You see, student, obviously, you see, if you draw a perpendicular line here to the surface, exactly angle of incidence, angle of, if you draw a perpendicular line like this, angle of incidence, angle of reflection will be same. Perpendicular line like this, angle of incidence, angle of reflection. Okay. So that will always happen. Angle of incidence equal to angle of reflection always happens, and as it is a law always happening, or it is happening always, that's the reason he has assumed it as a law. Both are right. Okay. Second law, incident ray, reflected ray, and normal all should lie in the same plane. Okay. So let us take this figure, student. Okay, you see here, what is this figure? So it's same plane, he said, right? So this is x-axis, this will be y-axis, the this is z-axis. Z-axis is nothing but that is coming out of your screen. Now, where is normal? Sir, normal is in xy plane. XY plane. Where is reflected ray? Reflected ray is also in XY plane. XY plane. Where is incident ray? Incident ray is in YZ plane. You see Y axis, Z axis, YZ plane. So student, this will never happen. Okay, this combination will never happen. Then what combination will happen? The combination will happen like this. Okay, by X plane, Y plane, Z plane. Now you see, student, where is normal? ZY plane. Where is incident ray? ZY plane. Where is reflected ray? ZY plane. All the three are in the same plane. That is what your law is saying. Incident ray, reflected ray, normal. All lie in the same. Okay. So these are the two laws of reflection which may come for, there is very light chance, huh? Very little chance. Okay, the geometrical question that may come for 1 mark. Okay, let us see after learning what is the law of reflection. The first formula is this beta. Only one formula I gave till now. Angle I equal to angle R. Okay, let us see some geometrical questions on this topic. Yes, the first question is on the screen. Many students are absent. Tanish, Megha, who else? Avdan. 3 students are absent. Oh, Tanushri, 4 students. Narendran, Shayan, Maya, Rujuta, right answers. Tanushri, where were you, student? You are attending this session for the very first time, this chapter. I thought you will be in the first place.
No, sir, I
Karthik.
was helping my mom with something.
Okay, so I have started this particular chapter, student. Just now, I have just finished for one formula. Angle I equal to angle R. Only one formula I have finished. Angle I is nothing but angle of incidence and normal के बीच में angle है बेटा. Angle R is nothing but reflection and normal के बीच में angle. Okay. Now the first question is which is right answer. So you see student, surface and normal, they will always be 90 degrees. If this is 60, this should be 30. If this is 30, this should be 30. Tanushri, A is the answer beta.
Okay,
So
sir.
yeah, okay. So this is 60 means this should be 30. If this is 30, this will also be 30. Angle I equal to angle I. So A is the right answer. Good student. Second question on the screen. Very good, Karthik, Rujuta, Narendran, Maya, Shayan. Very good. So student, whenever such question comes, you should follow one method. Incident ray, whenever it hits mirror, please draw the normal first. Then complete the path of that particular ray. After coming here, after it will reflect and bounce back like this. That is what the reflection is, right? No, Tanushri. Yeah. You can see, student. Find the angle of reflection, student. So he is asking this angle beta. What will be the yellow color answer? Angle R equal to angle I. The yellow color will be equal to the green color. Then what is green color, sir? This is 30. This should be 60. Why? Mirror and normal both will be 90. Total will be 90. So if this is 30, this is 60. If this is 60, this will also be 60. B is the answer. Okay? Okay. Next question on the screen. So please try to complete the diagram and then give the answer. Huh? Complete the path of the light, then give the answer. Please put your pen on the paper. Try to complete the path. You may not get the exact answer, but try to give the best answer. Light ray, you see, soon it incidented. I should have drawn this normal line, but it is already there. Rujuta, wrong answer. Maya, right answer. Karthik, very good student, right answer. Please complete the diagram. Soon it incidented, it should reflect back. So it will be coming like this. But you see mirror too. Again it's a mirror. Soon it has incidented. I should draw the normal line. Again this will be reflected. This is the complete diagram. We can do it in two ways. There are no two ways. There are 3 to 4 ways. Rudita, now you are right student. Shayan right. Narendran right. Okay. Okay, so this is completion. After that, what you need to do? So please start with whatever is asking. He's asking angle of reflection from mirror to. So he's asking this green color angle. If this you want to find this angle. What is this angle? This red color angle. If red color angle is known, green color. How can you find red color angle? You're able to see some triangle over here, but you should also see this particular. You see, this is 60. This will be 30. If this is 30, angle of incidence equal to angle of reflection 30. 30, this is 90, this is x. 30 plus 90 plus x equal to 180. So what will be x beta? 180 minus 120, x will be 60. If x is 60, this will also be 60. Yes, Narendran, why this is 90 beta? Why this? So I would have taken like this also, normal line. Normal line. So why this is 90?
Sir, it is perpendicular to mirror 1 and mirror 2. And then, like the angle between mirror 1 and mirror 2 also will be 90. So
Very good, absolutely. Okay, student, here you see mirror 1 and mirror 2 angle is 90. That's the reason their normals also will have 90. Okay. Yes, Karthik, what is another way, student?
Sir,
You said another way also. Which way?
sir, the triangle way, sir. So the 360 and 90 right angle triangle.
Also, this one.
Yes, sir.
Okay, so yeah, you see, it's a geometry. You what he is saying, so this is 90, this is 90. If this is 30, this will be 30. Why? Why? Because two parallel lines and the transversal. This is 30, this will be 30. Alternate angle. If this is 30, this will be 60. That's many geometrical values can help you here. Tanushri, understood beta?
Yeah, sure.
So please take some time, try to complete the diagram first, then give the answer, student. Take the help of two things will help you. First is one formula what we have derived, angular equal to angular. Second thing is your mathematical geometry. Complete the diagram first. So before discussing sample paper, I'll give how you need to attempt to physics numerical questions, student. Because there will be a lot of numerical questions in physics. Or this time they are increasing case-based questions, sir. So your 3 mark question, 2 mark question also you can feel something like case-based only. Right answer, Narendra. This will reflect back. Angular equal to angular. This will be 25 degrees. This will go here. Again mirror to. So soon it is hitting. What should I draw? I should draw the. Again it will be. Maya, right answer. Rujita, right answer. Karthik, right answer. Tanushri, right answer. Yes, yes, absolutely right. Same question. Okay, wonderful, student. Okay, so student, if this is 25, this will be 25. If this is 25, this will be 65. If this is 65, this will be 60. This way also you can give, or else angle sum also is right answer. Okay. Okay, so if this is 25, so 25, this is 90. Why? Because you see here is 90, their perpendicular normals will also be 90. So this is x. X plus 90 plus 25 equal to 180. X equal to 55 or 65. So if this is 65, this will be 60. Okay, many ways you can do that. Rujuta, right answer. Shayan, will you attend this weekend class or not this time?
So my exams get over tomorrow, so I'll attend.
Okay. I'll probably keep in the evening only so that I'll not disturb your morning schedules. Maya, right answer. Do you regularly go to church on Sunday morning? Shayan?
Yes, sir.
So I'll keep it in the evening. Narendran, right answer. Angle of incidence for the plane mirror is 60. What is the angle between normal and mirror, student? There is no requirement to go for the question. This is mirror and normal is always drawn 90 degrees to the mirror. So the answer should be 90 degrees. There is no requirement of this sentence at all. Yes, Karthik, no. Okay, so he's just asking mirror and normal. So always it will be 90 degrees. Normal by English meaning only 90 degrees to the mirror. Right answer, Narendran. Please draw the diagram, a rough diagram. Even though it is for 1 mark, a rough diagram will give you the right answer. Students who are giving the answer in the direct sense, you may miss it. Yeah, Rujita, you missed it already. You have not drawn the diagram. Incident ray make an angle 35 degrees to the plane mirror. So I'm assuming the black color is a plane mirror, green color is an incident ray. Soon the incident ray comes. What should I draw? I should draw the normal. But as this is a mirror, this will reflect back like. Did you see? At least this diagram should draw, student. Yes, Rujita, good. Maya, right answer. Shayan, very good.
So with the plane mirror means it's not
Very good, very good. So that is what the question I took, okay? Incident ray making angle 35 degrees with the plane mirror. So plane mirror is this, incident ray is this. This is 35 degrees. If he is not mentioning anything like this, by default you should take with normal 35 degrees. But if he is mentioning something, please take that particular word. Okay, he mentioned 35 degrees with the plane mirror. So this is 35. What is he asking, student? He is asking this particular angle. Okay. Yes, Tanushri, no beta. So that was, yeah, this is 35. You see, this will be 55. Because total should be 90, normal and mirror. If this is 55, this will be 55. Okay, so if at all he has not mentioned anything, he just said incident rays making angle 35 degrees, then it is with the normal 35 degrees. Then this will be 35 degrees. But he has mentioned with the plane mirror. So now you should calculate this as perfect. Should I repeat it, Tanushri?
Yes, sir.
And should I repeat it?
Yes, sir. Can you repeat it?
Yeah, yeah. You see, student, incident ray making angle 35 degrees with the plane mirror. Plane mirror is this, incident ray is this. It is making 35 degrees with the plane mirror. So this angle he has given. Now he is asking this angle. So what is this green color angle? Green color angle will be red color angle. And what is red color angle? Mirror and black color. Black color and blue color total should be 90 degrees. So this is already 35. So this will be 90 minus 35. Total is 90. This is 35. This will be 90 minus 35. This is 55. If this is 55, this will be 55.
Okay, sir.
Let me see who will give this answer. Yes, Maya, Tanushri, right answer. Rujita, right answer. Narendran, right answer. Good. Come on, Karthik and Shan, give some answers.
Sir, I didn't give the answer.
Are you kept some question mark? Previous one. Karthik, right answer. Shayan, right answer. Tanushri, you gave. Achha, that was the previous question. Okay, a ray of light incidentally normally on the plane mirror beta. You see, again you need to draw. There is a plane mirror. A ray of light incidenting normally 90 degrees beta. So incident ray is this, making 90 degrees with the plane mirror. Okay, but soon the incident ray hits. What should I draw? I should draw the normal. Normal to whom? Always normal is with the respect to the surface. Now you see, student, your green color normal and your green color incident ray and blue color normal, they both are on each other. So is there any angle formed? Zero is the angle. So angle of incidence is zero. But you know angle of reflection equal to angle of incidence. So obviously that will also be zero. What does that mean? What does that mean? The green color light is falling like this. It will go back like this only, will just bounce back like this only. That is what the meaning of 0 degrees. Okay, so the way it came, the way it go back. Just. Yeah, so that was the story of reflection, student. Okay. Now let us go to the refraction of light. Okay. Yeah, we finished this part. We finished this part. Let us go to the refraction of. Okay. Okay. First of all, let me explain what is refraction. Okay. So reflection was nothing but bouncing back of the light. This is what we have said. Just it was bouncing. Okay. Now what is refraction? Let us see. Yeah, when a straight line I'm passing it through the particular glass, you see it took some curve. It is not straight now. Exact in the glass, it is somewhat curvy. Let me draw the line and show you that. Okay, you see perfectly. Yeah, you see it's not a straight, so it's just something like curved straight. So that means some bending is happening in the line exactly at the interfaces. Okay. And that's the reason, student. What is refraction? This is what I have shown you refraction. So it is not a myth. It is perfectly the refraction. It is possible. Okay. And then what is the meaning of refraction? The bending of light rays as they pass from one medium to another is called refraction of light. Okay. So students, by nature, light will travel in only straight line. You see, there is a white color light coming. It is traveling in a straight line. When from here to here it is air beta in the air, as from here to here there is no change in medium, it is traveling in a straight line. You see now it has entered the glass pane. It should have traveled in the straight line only, but will it travel in the straight line? No, it bended like this. Again it bended and then started again. The light is traveling in the glass pane only one medium. So in the glass plane the light is traveling again in the straight line. The light should have traveled in the straight line only outside, but now here the light has changed the medium from the glass to the air. Medium is changed, again the light bended and started traveling. So whenever there is a change in medium, light in spite of traveling straight line is bending and then traveling. Whenever there is change in medium, instead of the straight line, it has bended and then started jumping. So that's the reason bending of light is happening whenever there is a change in medium from one medium to other. And that is called refraction of light. Okay, Rujita, understood beta?
Yes, sir.
No.
Understood.
Okay. So yes. Now the question comes, sir, bending is happening. Which side it is bending? Now again, you should ask, so what is the reference first of all? As I said, for the reflection, what did I say? Who is the reference? For the reflection, we have noted that always this particular center line, which is nothing but normal, is the reference. Similarly, for the refraction also, we will again take normal as the reference. Okay. So normal is the reference. So now we should know it is bending away from the normal or towards the normal. It is bending away or towards. Let us think straight. Okay. Now let us consider one situation. You see, where is the light coming from? See the arrow, please see the arrow. Light is coming from air to water. Okay. What is air, student? You all know air means the molecules are somewhat loosely packed. Air molecule. What is in air? Nitrogen, oxygen, all are gases. Okay. They are loosely connected. In water, H2O, they are somewhat, they are not so strongly, they are somewhat closely packed. Not very slow, very strongly, somewhat closely packed. That means I am calling rarer because the molecules are sparsely available. Atoms are sparsely available here and there available. I am calling it denser because somewhat molecules are water molecules, hydrogen molecules, oxygen molecules, somewhat more concentrated. So rarer, denser means that, student. Okay, rarer means inside that atoms are somewhat sparsely available. Denser means there are closely packed. That is what the meaning of rarer and denser. Okay. Now, how is the light traveling? Rarer to denser medium. How the light will should go naturally, it should go in straight line. You see, as the medium is not changed, it is going in a straight line. So if at all there is no medium change, it should have traveled in the straight line. But as the medium is changed from air to water, it will bend. It will bend. How is it bending? Here is the normal. Sir, light instead of this red color, it has bended towards the normal. You see, green color bended towards the normal. Normal is here. the light is moving towards the normal. That's the reason. Please remember the shortcut. Rarer to denser, light bends towards the normal. RDT. Rarer to denser, light bend towards the normal. You see, light should go like this, but it is bending towards the normal. Rarer to denser towards the normal. Okay. There may be another situation also, student. Denser to rarer also it may be. Okay, you see, denser light ray is coming from here and going to air. Denser means water closely connected atoms are. Air sparsely connected, somewhat farther, sparsely. Okay. Now you see, light it should travel in straight line. It is traveling in straight line, straight line. It should have traveled straight line. But as the medium is changed from water to air, it will bend. This side is bending, it is bending away from the normal. You see, normal is this, it is bending away from the normal. That's the reason. Please remember the shortcut denser to rarer away, dara. Denser to rarer away from the normal, dara. Okay. Okay, so now if you have understood that rarer to denser, denser to rarer, let us see some activity which you need to remember this activity closely. Many questions can come, but only with this activity, any activity output can be expected or any output activity can be understood. Okay. Okay, let us see this activity. Okay, students, you see, students, there is a glass. In that, you have thrown a coin. Obviously, coin will get settled on the surface. Okay, now you are observing from outside the coin. What will you observe? You will feel somewhat coin is here. Okay, you will feel somewhat the coin is here. If you are not realizing, increase the water more. You see, in the cup B, I have increased the water content. Now you see your eye is feeling the coin is over, but really, where is your coin? Your coin has settled on the surface of the particular bucket, surface of the water. Okay, at the bottom surface of the water. But what is your eye feeling? Your eye is feeling over the drop. The particular coin is here. It is floating. Okay. Now what is that? How is it happening? I'll just give a clue. You see, student, the light might have been traveling like this the light might have been traveling like this. After hitting, it is reflecting from the coin. So now from the coin, light should have traveled in the straight line. Definitely up to here, light travels in straight line. If there is no change in medium, light would have traveled in the straight line. But now, as you know, there is a change in medium. Let me draw the normal at the junction. Normal. Now, from where the light is moving from where to where? The light is moving from denser to rarer. Denser to rarer, what is the shortcut? Away. That means this is the normal. Light should go away from the normal. That's the reason light is moving like this. That's the reason light is moving away from. You see, this is my actual light path, but denser to rarer away from the normal. That's the reason light is moving like this, away from the normal. Now, what your brain will sense? Our brains are programmed, our eyes are assumed the light travels in a straight line. My brain and my eyes are feeling okay, the light might be coming from this particular point line. Okay, light might be coming from this particular point line. This is what is nothing but illusion or the cheating of your eye. So refraction is like little bit cheating only, student. Okay, which is apparent. So here there are two things better. Two things are there. What are the two things, student? Here you see where is your coin, sir? From the surface, from the edge, from the top surface of the cup on the bottom surface. This is my actual depth of the coin. Here is your actual depth. But what is your apparent depth, student? Apparent means what is your eye feeling from the top? Here is what I feeling. Okay. So Karthik, so this is apparent, this is original. So apparent is more or less better?
Sir, apparent is less.
Less, okay. So you see your brain in your eye is feeling only this much height, but actually the height is this much. So that's the reason you should remember this statement. Remembering this statement is not so easy. That's the reason you need to remember this activity. Apparent depth is always less than original depth whenever you are watching from rarer to denser. Okay, so this is a big statement you can't remember. Please remember the activity. Rarer to denser means bucket ka bahar se bucket ke andar. You're watching something from outside of the bucket to the inside of the bucket. Rarer to denser. So just remember, okay, in the coin diagram, we have seen our eyes are cheated by less depth. Our apparent depth is less than original depth. Okay, this is one activity. The next activity, there may be another situation also, denser to rarer also it may. Okay, let us take this activity. You see, student, assume this is some swimming pool. You are lying on the bottom of the swimming pool. It is full of water now. Ask one of your friend to catch the coin with his hand like this with two fingers and just keep on the surface of the water, upper surface of the water. You observe it from here. What you feel, you will feel coin is somewhere very farther distance, very farther distance. Okay, you will feel it. You can just do it in one of the swimming pools, whenever you're feeling. What does that mean, student? What is actual depth? My actual depth is here to here. This is my actual depth. But what is your apparent? What is your eye feeling? Your eye is feeling this much depth. Okay. So yes, Tanushri, is apparent depth more? Yeah, actual depth more better in this case.
Apparent length is more.
Yes, apparent length is more. What your eyes is feeling is very far the distance, but what is your originality is very less. So that's the reason apparent depth is more than actual depth here. Apparent depth is more than actual. Rujita, understood, beta?
Yes, sir.
Okay. Yeah. So now with this example, any question is given, you can find the answer by your. Okay. Let us say this activity. This is a question. Okay. Case-based question, whatever you assume. Okay. You see, student, this is a sea. From the surface of the sea, these are the real depths. The fish is at the 4 meters below the top surface of the sea. And the bird is at 6 meters above the top surface of the sea. These are the real things. Okay. Now the questions will be like this. Fish viewed by bird. Now this bird is seeing the fish. Will the apparent depth, what does that bird feel? Is the distance greater than 10, less than 10, or equal to 10? What does the bird feel? More than 10? Yes. So just recollect that previous example, previous activity. So which activity will match here? Just recollect the previous activity. The bird is outside, the fish is inside. So which activity will match? Try to give the answer in that way. Narendran, right answer. Maya, right answer. Just relate with that activity. Tanushri, very good, right answer. Rujita, wrong answer. Narendran. Huh? Narendran, why did you change your answer? Narendran, you are giving two answers, student. I don't know which is right.
So the bird is directly above the fish.
So what? The light has two different mediums, air and water. Light has, whenever light is going through two different mediums, refraction happens.
So if it's going normally also it will reflect.
Yes, definitely.
Okay.
Okay. Yes, students. No, Rujita. Come on, Shayan, give the answer. So please recall. Yeah, Rujita. So which activity is this question? Is it L or R? Left activity or right activity? The bird watching from outside, the fish is left, right?
Yeah. No,
So
sir. The question was the fish is seeing the bird, right?
fish viewed by bird. The bird is
By
watching
the
the
bird.
fish. Okay.
Okay, sir.
Fish
Okay.
viewed by bird. Shayan, which activity beta, left or right? Shayan.
Yes, sir.
So which activity you are matching that question with?
The
Bird.
second.
Yeah, you see, student, bird is watching fish. Bird is in the air, fish is in the water. Which activity, left or right? Huh?
Left.
Left, right, yeah. So in the left, what did happen? What is your apparent? What was your brain feeling? The apparent depth is less. Original depth was more. So that's the reason, student. Okay, so that's the reason the less than. So the bird is feeling the distance is less than 10 meters. Yeah, Narendran. So I did not frame this question for that particular normal to normal. Okay, I just framed it for the different two mediums. So yeah, the bird may be here also. Yes. Yeah, Narendra, what's your doubt now?
Then nothing. So I was gonna say like when you pass the light normally in the glass slab, it was not refracted.
So glass slab, not refracted, you are saying. So will it reflect always? Is it that you want to say?
No, sir. I'm trying to say that it will pass straight.
It will pass straight. So do you mean that bird will not able to see the fish?
Sir, I'm saying it will be the actual apparent depth will be the actual depth.
Apparent depth will be the actual depth. Hmm. So here, first of all, the bird watching means, first of all, you see here the question I'm asking for refraction. What the bird feel? Okay. So the light will refract, reflect. The bird can only watch the fish if it reflects. Okay. So here the two things you are mixing, student. So I'm not interested about reflection. So you are saying the bird will feel the exactly 10 meters, right? Apparent depth, actual depth. Let me think one second. So bird is so the light ray is coming with that. So as there are two mediums, so definitely the apparent no students. So I don't think so. Okay, let me analyze again that particular thing. So right now I was speaking only apparent, so it is less than 10 meters according to that. Okay, according to. I'll just come to that particular part when I finish this particular refraction portal topic. Okay. Yeah, the next question. Bird viewed by fish. Bird viewed by fish, right? So now the fish is watching bird. What will be the apparent depth? Less than 10, greater than 10, equal to 10.
So can you repeat your voice was breaking?
Bird is, sorry, fish is watching the bird, student. Yes, right answer, Maya and Narendran. Fish is watching the bird. So which activity? Just recall the activity. Yes, right answer, Rujuta. Tanushri, right answer. Come on, Shayan, Karthik. Not able to see your answers. Fish is watching bird, student. So just recall the activity with this. Fish is inside water, bird is outside water. So what is your apparent is more, real is less. So apparent will be more. So that's the reason the answer will be greater than 10 meters. Okay, so at least give this answer. Karthik, Tanish. Tanish, you have joined but not given even one answer. Should I welcome you? The real depth of the fish is 7 meters to observe in a boat. The depth of the fish would be. Yes. Right answer, Rujuta. Tanish, wrong answer. Narendran, wrong answer. Karthik, right answer. Narendran, what was the confusion, student? The real depth of the fish is 7 meter.
So
To
I didn't
observe.
see the observer part.
Acha, you have not seen the question properly. Okay. See it and give the answer again. Maya, right answer. Please just correlate with that activity. Fish is in water, observer, boat is in air. Yes, Narendran, right answer. Shayan, right answer. Yes, Tanushri.
So did you get my answer?
No, yes, I got it. Okay. Right answer. Yeah, this question. Airplane is flying at an altitude of 7 kilometers from the surface of the water. What would be the observed height of an enemy submarine observing this plane? You see, submarine is in water, plane is in air, denser to rarer. Narendran, right answer. Maya, right answer. Tanushri, right answer. Rujuta, right answer. Come on, Karthik. Shayan, Tanish. Tanish, you should relate this question with the two activities, whatever we have done, we have just seen. I don't know whether you have joined before that or after that. And you're not switching on your camera, Tanish. Yes, Tanish. Right answer. Okay, so greater than 7 kilometers. Just relate with that activity. Okay. Yeah, that was the nothing but understanding what is refraction. Something. Okay. Now you see all our eyes are cheated here. So how much did we get cheated? So that is nothing but the refractive. How much cheating has happened? That is nothing but the refractive index. So that effect is happening, student. But now you should, that effect is our feeling. But physics doesn't have any feeling, right? Physics want only the formulas, the numbers, the amount. Okay. So that's the reason we should know what is refractive index with the formula. Okay. With the real sense of the formula. How to measure it. Okay. Our feelings can't be measured. Okay, so right now the same answer. So Narendra may feel more than 7 kilometers, Narendra may feel 100 kilometers. I may feel 7.1 kilometers. Okay, that's the reason should we need to derive some perfect definition. Okay, so that is nothing but refractive index. So how much a substance can deviate you, how much a substance can affect the particular real scenario. Okay, so what is its definition? Okay, the definition is like this, student. The ratio of speed of light in vacuum divided by speed of light in a medium is called refractive index. Okay, let us take some example. You see, suppose from sun there are thousands of millions of sun rays. I am assuming only one ray is coming. So obviously, student, definitely outside atmosphere, you see, Earth's atmosphere is from 0 to 500 or 600 kilometers only. After that, entire everything is vacuum. Okay. So I am assuming that the sun ray is coming through the vacuum first, then it is entering the air. Or this here example I have taken glass. Now, what is happening here? You see, whatever the sun rays from the sun they are entering, they are at a speed of 3 into 10 power 8. Please remember this value, meter per second. C is nothing but speed, 3 into 10 power 8 meter per second. You see, once they're entering vacuum, vacuum means what, student? Nothing. There are no particles at all inside. They are neither dust particles nor air particles. They are nothing. So will it just reduce its speed? No. The light ray will continue its speed to travel in 3 into 10 power 8 meter per second only. Okay. But once it enters another medium, glass have some particles. Okay, glass have some different particles, so nothing but atoms. So that's the reason, student, the light will reduce its speed. Their light will also bend its direction. Okay, so whenever it is entering in the glass, the same light, the velocity is reduced. The velocity reduced, that doesn't mean you can catch it. It was 3 lakh kilometers, it will be 2.99 lakh kilometers. That's all. Okay, so two things are happening here. The velocity is reducing and the bending effect is happening. Now, what is refractive index? Mu of the glass. Now, here I am speaking about the glass. Is nothing but initially it was traveling with 3 into 10 power 8. In here, it might be traveling in 2.9 into 10 power 8. So, C by V, which is nothing but 3 into 10 power 8. Initially in the vacuum, which is 3 into 10 power 8 divided by in the medium 2 into 10 power 8, 2.9 into 10 power 8. This value is nothing but refractive index. This value is nothing but refractive. So you see, student, some students, if you are not understand, you can assume it's something like a football ground, weekdays, nobody is there. You will run at a very fast speed. Nobody is there to stop you. But exactly at the weekend, the ground will be full. You need to reduce your speed. You need to bend left and right. Okay. Now, what is the particular this football ground refractive index? Whatever you have traveled in weekdays with full speed divided by your speed reduced on that particular day. The ratio of that is nothing but refractive index. Okay. Now, sometimes there you may not analyze this much depth. So by this also you can feel it. You see, mu value is 2, mu value is 2.5. Now in these two, whose refractive index is more? Obviously 2.5 is more. What does that mean, student? That means in this football ground, there are many players. So obviously light will bend more, speed will be less. Compared to this football ground, the players are less. Light will bend here also, but the bending will be less. Light will reduce its speed here also, but the speed will be somewhat less reduced. Okay, so by looking at the values, you can just say, sir, this is crowded, the speed will be reduced more. This is less crowded, the speed will be reduced, but not so much. Okay, so these are the real meanings of the refractive index. This is the formula of the refractive index. Understood, Tanushri?
Yeah, sir.
Okay. Okay, so with this concept, let us do one more thing. You see, students, some of the questions are like this. They will give refractive index of different medium. You see, something like plastic, diamond, water, something. So now you see, if a light enters from air to water, light will bend. That means refractive index is there. If a light enters from air to diamond, the light will bend because different medium. Now the question comes, in which substance the velocity will be more, speed of the thing will be more. You know the formula, mu equal to c by v. You should see how are mu and v connected. They are inversely connected. Now whoever's refractive index is more, which velocity will be less. Refractive index more means what, better? The football ground is fully crowded, then you should reduce your velocity. Similarly, in this case, whose refractive index is more? B. Whose velocity will be less? In which substance velocity will be less? Obviously in B, because here the crowd is more. The refractive index is more. Okay. With that, let us do some of the questions. Ryan, right answer. Tanish, right answer. Narendran, right answer. Rujita, right answer. Maya, right answer. Come on, Karthik, Tanushri. Yes, Tanish, please explain me. How is your answer right? How did you do? No, Tanushri. Yes, Tanish? Why Tanish is not speaking, not showing his face? I'll remove you, Tanish, if you not switch on your video within 5 minutes. Okay, so student, let me take the help of maths first. Okay, he's telling refractive index is less than 1. Mu less than 1. But what is mu formula? C by V less than 1. C is nothing but velocity of light in vacuum. V is nothing but velocity of light in substance. If you cross multiply this, C is less than V. You see, in the vacuum, there are no obstacles. So velocity of light will be more in vacuum, velocity of light will be less in substance, but he is giving in vacuum the velocity is less. Is this possible? Answer is no. C will be maximum beta. In the vacuum, 3 into 10 power 8 is maximum speed. In no other substance you can get either equal or more than this. All other substance you will get less than this, something like 2.99 into 10 power 8, something like 2.97 into 10 power 8, but you will not get 3 into 10 power 8 or 3.1 into 10 power 8. You will not get. Why? Because vacuum is having no particles, nobody is there to disturb you, you can run at this speed. Okay, but other substances there are some particles, so definitely they will stop your speed. So here I am getting, in the vacuum the speed is less than other substance. Is it right, Tanushri?
What, sir?
Is it right? In the vacuum, the speed will be less than other substances.
It's right.
It's how better in the vacuum. You see, vacuum means nobody is there. So you are running in a football ground where no player is there. What will your speed will be? Will it be less or more?
More.
More. Now on the weekend on the same football ground, some players are there. What will be your speed? More or less?
Less.
Less. You see, that means in the vacuum the speed should be more than any other substance, because every other substance which I am taking as V, it will have some atoms, but vacuum is empty. That's the reason speed in vacuum is more. Speed in that football ground is more where there are no players other than the football ground where there are some players like. Understood, Tanushree?
Yes, sir.
Yeah, like this. You see, if you take glass, there are some particles which will reduce your speed. In vacuum, there are nobody. So speed in vacuum will always be more than any other things. Okay, okay, Tanish, I am removing you from the session. Happy to meet you tomorrow.
Sir,
What happened?
sir, I'm having a bit of network issues, so I'm not unable to
You could
respond
you
properly.
you could say the same thing in the chat also, right? Is my requirement is there to shout on you, student. You're class 10 student. You're not a class kid of class 2 or 3. You would have said the same statement in the chat after 2 times of repetition. So have some etiquettes. Yes, glass has dash index of refraction than air.
Sir, greater.
Achha, you get the answer. Okay, so give in the chat box. I'm not speaking about the answers. Answers you are giving in the chat box. I'm able to see. I was asking that you are not switching on the camera. The reason you would have typed in the chat box is that. Rujuta, okay. Tanish, right answer. Narendran, right answer. Rujuta, no beta. Think, Rujuta. You see, so student, whenever such question comes, please look the direction of the arrows. You see, your final board paper also sometimes paper will not be so clarified. You should check the direction. Okay. Now you see, student, the light is coming from air to glass. Now he's asking whose refractive index will be more. Is it air or glass? Will glass have more index of refraction than air, less index of refraction of air? Yes, Rujita, right answer. Come on, Shayan, Karthik. Shayan, you gave the answer, beta. No. Okay. Maya, glass. Glass will have some atoms like this. Air is loosely atoms, beta. So where is refractive index more? Where is the crowd more? No, Shayan, Maya, you all are getting confused. Student, refractive index is nothing but you see here more persons are there. Here refractive index will be more. Less persons are there. Refractive index will be less. At least think this one. Now you see he's telling glass has dash index of refraction than air. You see glass molecules are closely packed. Air molecules are loosely packed. When you touch the glass, it will be solid. In solid, the atoms are closely packed. When you touch the air, it will be very loose. The atoms are loosely packed. So in this way, at least you try to give the answers. Yes, Shaya, now you're right. Maya, right. Okay. Obviously, glass will have more reflexive index than air. Okay, I'll say you another way also how to. So if at all the question is like this with arrows, you should take the help of arrows also sometimes. You see, the light is coming through the air. So light travels in a straight line. Definitely light would have traveled in a straight line. But is the light traveling straight line? No, light has bended. Now where is this bending happening? This is normal. Light is bending towards the normal. In the glass only I am speaking. Light is bending towards the normal. Normal is here. Light is bending towards the normal. So two words means RDT. Rarer to denser only two words will come. So that means this is rarer, this is denser. Light is traveling from light air to denser medium. Okay, in that way also you can explain. Okay, so please remember this only one value. I don't know whether he is asking about the water, air also, I don't know. So air he is mostly taking it as again one. Diamond you remember, student. When I go back and check all the sample papers, then I'll give the more clarity whether you need to remember some of the values or not. Okay, right now what I have an idea is just remember the diamond. Yes, Rujita, why the diamond value is more? You see, you will not find any other substance whose refractive index is more than diamond. Why like that?
So because of its complex structure, right? It undergoes multiple
It undergoes
refraction,
multiple.
multiple refraction, and it has like a shiny appearance because of that.
Oh, you have mixed many things, but not the exact one. Yes, Narendra?
Sir,
Yes, why diamond is having the highest refractive index? Don't know? Okay. Maya, do you know Maya?
Because of total internal reflection.
No, I did not start total internal reflection. I am only asking refraction. Okay, so student, what is diamond? We have read in chemistry. Diamond is the hardest natural substance on earth. What is hardest, student? Hardest means the carbon atoms are very, very closely packed. Very, very closely. You see, it's totally overcrowded. So if at all any light want to pass through the diamond, it will definitely reduce the speed and bend more. Why? Because totally overcrowded. Diamond is the higher, hardest natural substance on earth. So more crowded, more refractive index. Simple answer. Understood, Rujita?
Yes, sir. But for this question, like you said, more than air, there can't be any other greater value, right? So I
No, 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 no. I said no. Nobody can be less than air. I said less than vacuum. I said refractive index.
that is vacuum and this is air. Is it?
No, no. You all are getting confused. See, first of all, you are getting confused with two things. If I am speaking in refractive index, it's only the tightness. Okay.
Okay.
You see here refractive index. You see here I'm taking three substances. You say me whose refractive index is more. A, B, C. Now you say whose refractive index will be more.
See, sir.
C. Over all the atoms are overcrowded. That's the reason refractive index is more. What does that mean? What does that mean? If at all light is passing through that particular substance, the speed of the light will be reduced. The speed of the light will be reduced. So now the question is, as we know naturally, the diamond is the hardest natural substance. What does that mean? Inside diamond, whatever the carbon atoms are, they are very, very closely connected. Obviously, its refractive index is more. Okay, and that's the reason the speed will be less in this particular diamond.
So
Okay.
it will be lesser than 3 into 10 power.
Yes, yes, it will be lesser than 3 into 10 power 8.
Oh,
The speed will be lesser, but not the refractive index. Okay. So
okay, sir.
in vacuum, you can say speed is maximum. V is maximum, which is nothing but we are taking it as C. But what about the refractive index? Refractive index is less, which is 1. So there cannot be any substance whose refractive index is less than 1. There cannot be any substance whose speed can be more than 3 into 10 power 8. Two different things are there. Understood now?
Okay, sir. Yeah. Got it.
Okay. There can't be any substance whose refractive index is less than 1. Vacuum itself is 1. Vacuum and air, he is considering it same in your book, but it's practically wrong. Vacuum means nothing is there. Air means some nitrogen molecules will be there, some oxygen molecules will be there, right? But anyhow, so if at all I want to give a statement, finally I should say there can't be any substance whose mu value will be less than 1. There can't be any substance whose inside the speed of the light will be more than 3 into 10 power 8. Students who have understood, thank you. Students who did not understand, leave it. The next question. The speed of light in substance and that in air. So there is air, there is substance, X. So if I am sending a light, obviously light will travel in 3 into 10 power 8 in vacuum. But he said it is passing through air. And he said in the air also he's taking 3 into 10 power 8. So he's neglecting the air molecule very sparsely. But when it is entering the substance, he said 1.25 to 10 power 8. So the speed is reduced now. You see, speed is reduced. Now he's asking you mu of the substance. You have the formula C by V. Maya, wrong answer.
Sir,
Naren. Acha, okay. Rujita, right answer. Narendra, right answer. So you did not give the answer. Okay, sorry. That was the previous one. You have the formula C by V. C is nothing but he has taken the light is traveling from air. So C will be velocity of the light in air, which is 3 into 10 power 8 divided by V. V is nothing but velocity of light in a substance. How much did he give? 1.25 into 10 power 8. Yes, Maya, right answer. Tanushri, no student. Did you take the same parameters, Tanushri, 3 by, did you take it in a reverse way?
Yeah, sir. I took it in reverse.
Reverse way, right? You see, it is C by V. C means from a vacuum to the substance, but in spite of vacuum, that fellow has given air here. So you can directly take C as air speed. Okay, so it's 10 power 8, 10 power 8 cancel. 3 by 1.25, which is nothing but 300 by 125, which is nothing but 2.4. Karthik, are you there, student? Karthik? I don't know, Karthik. Shayan, are you there?
Yes, sir.
Okay. The refractive indexes are given. He's asking you in which the light will travel slow. Different mediums are given. Substances. Medium is nothing, substances. Now he's asking which substance the light will be slow, student. Slow. Right answer, Narendran. Maya, right answer. Rujita, right answer. Shayan, right answer. Come on, Tanish, Tanushri, Karthik. He is asking light travels slowest. He is speaking about V. Tanushri, check your answer. Tanushri, which formula did you use? You say me. I'll help you out, student.
The one U is equal to V by C by V.
C by V. Now you see, he is speaking about the light travels V medium. Different mediums are given. So he is speaking about V and mu. How are they connected, beta? Directly or inversely?
Inversely.
Inverse. Okay. You see, you should not take C. He is speaking about different medium. Medium speed is this. This is speed in vacuum. They both are reverse. Now he's saying light travels slowest. So V should be low. What should be mu, student? Low or high?
High.
High. So whose value is high here? Glass is 1.53. Carbon disulfide is 1.63. So obviously the answer should be D. Understood, beta?
Okay, sir.
Okay. So the mu, whoever mu is high, that's velocity will be less. Okay. So yes, Narendra, say me the formula of carbon disulfide. Maya, carbon disulfide formula.
CS,
C
S2.
S4. Okay. Yes, Rujita.
Sir, C2S,
C2S. Okay.
CS2, sir. Either one.
Okay. Acha, okay. Maya gave the right answer. I think your voice was breaking, student. Okay. CS2 is the right answer. Okay. Carbon disulfide. Student, yesterday we have read silver sulfide Ag2S. What does that mean? Silver have +1 charge, sulfide has -2. Sulfide is always -2. And disulfide in the name only you can see. Sulfide means yes, disulfide means you see. And sulfide means -2. -2 into -4. Carbon will have +4. You see, balanced. Okay. Yes. Shayan, what is the chemical formula of glass? Yes, Tanushri, glass.
I'm not sure, sir.
Sure. Anybody? Glass. Okay, right answer. Okay, yes, Narendra. SiO2 is the main thing. Other than that, we will have many things, sir, in glass. Okay, so silica, we say glass is made up of silica, SiO2, silicon dioxide or silica also. Okay, but there are other things also. Okay, major contribution is silica. Yes. Again, he has given refractive indexes, means mu is given. Now he is asking speed of light is maximum. You know the relation between mu and v. Right answer, Narendran. Maya, right answer. Rujita, right answer. Tanushri, very good, right answer. Shayan, right answer. Okay. So obviously mu is inversely proportional to 1 by v. Now that fellow is a v more, mu should be less. Listen, okay. All else you can just say, sir, in this ground only 1.31 less players, so speed will be more. That way also you can say. Okay, we'll stop it here. You just take this question and try to give the answer. I am just forwarding it in the chat box. Okay, so we'll stop it here. So I thought to cover, actually I thought to cover how many, 175 slides I thought to cover. But you see, I did not reach even up to half. Okay, so I think this is where I have stopped for the previous batch. So tomorrow also I'll take this session. So student, is it okay if I take from 5:30 to 7:30 tomorrow? Will you able to give half an hour more? Will you able to contribute half an hour more? I want to club two batches and to take more so that the syllabus may be completed. So please say yes or no from your side. Okay, Tanush, yes. So please type yes or no, student. Let me see the availability. Okay, Rujita, okay, two. I may join it. Yeah, Maya, it's fine. You already know the things and you don't have exam very recently. That's fine. Narendran, okay, but try to join early, Maya. Narendran, yes. What about Shayan? Okay, student, then that's wonderful. So I'll try to take 2 hour sessions so that I'll complete little more things. I want to just push out these basics and finally enter plane mirror and this particular mirrors, especially. Okay. Okay, so yes, Narendran. Okay, so yes, Rujita and Narendran, you're getting same answers. So probably you are right. Okay. Okay, student. Thank you.
Thank you, sir.
Thank you, sir.
Okay.
Thank